To officially begin things, hello everyone, and a very warm welcome to today's power packed session on Big Data Essentials, Hadoop, Spark, and Databricks. My name is Varda Ziawasi, and alongside me is Muhammad Mutahir, and we will be the moderators for today's ceremony.
Yes, just a second. We have just more students joining in. Um, all right. So yes, Assalamu alaikum. My name is Mohammed Mutahir, as Ms. Verda has mentioned. I am the program coordinator at ETL Online, and I am a student of sixth semester currently in my software engineering program. And I'm happy to moderate over here with Ms. Verda as well. And we have Sir Nofel Elahi, who's our esteemed speaker for today. But to officially kick things off first, those of you who are new over here, I would like to introduce ETL to all of you first. So ETL actually means and stands for Empowerment Through Learning. And when I say it stands for empowerment through learning, what I actually mean is if we are trying to empower Pakistan's tech future through community building, projects, career support, and a few of our own initiatives along the line. We are dedicated to fostering a vibrant online tech community and an online presence all over Pakistan because we're basically a non-profit organization that is working for free to provide free educational resources to everyone all over Pakistan. We have quite a few initiatives lined up, starting with, if I can share my screen, let me share with you our brilliant website first. Pardon the delay. And I'm also receiving a call for some reason. All right, I hope my screen is being shared and everyone can see it, right?
Yes, it is
Yes,
clearly.
Mutahir.
Thank you so much for saying yes and giving me the go. All right. So I'll start by just giving you a brief overview. This is a brilliant website. I'll share the links as well. And link to our portal over here will also be shared with you. But let's talk about our initiatives, as I mentioned, starting from community portal. Ms. Verda, can you explain the community portal initiative?
Yeah, sure, why not? So, our community portal is the place where tech enthusiasts connect with the industry professionals. Mutahir, if you could go to the portal and we could just show.
Sure, why not?
So basically, our community portal is a place where you can get all the information that is related to empowerment through learning platform. This is our main page, which shows that we are Pakistan's largest online tech community, and this is the place where you can showcase your achievements, share information, interact with other people, and there is a lot more to explore. So basically, to put it all this in a nutshell, it is a mixture of Discord and Facebook as well. Discord is a little too chatty sometimes and not, don't get the vibe of posting and achieving something. So, this is the portal where you can post as well, you can scroll as well, you can get the feel of using social media as well, and you can also get the feel of chatting with people. So, this is a whole social media platform designed just for ETL Online. So you all can go there and just explore it. A link to our website is shared in the chat. Feel free to go there and explore it. Nextly, we have our final year project advisory. Final year projects तो बेसिकली हर स्टूडेंट हर एक स्टूडेंट की डिग्री का एक इम्पॉर्टेंट पार्ट होता है, ठीक है? तो हम फाइनल ईयर प्रोजेक्ट्स में हम क्या करते हैं कि वी कनेक्ट इंडस्ट्री एक्सपर्ट्स with students who seek professional help for their FIP projects. So, our experienced advisors help students turn their final year project ideas into impactful solutions. And iske through, we help students and industry experts as well to connect through the platform of ETL Online. And all this is done to make sure that the projects are perfectly aligning with industry expectations.
Yes, I'll move moving on to open source project contribution. Sorry for the delay over there. Now, we also have an initiative about open source projects. Raise your hands if you know what open source actually means. तो मैंने ये देखा है कि ओपन सोर्स का ज़्यादा आइडिया नहीं है हमारे स्टूडेंट्स को इन द पाकिस्तान यूनिवर्सिटीज एंड एजुकेशनल इंस्टीट्यूट्स बट ओपन सोर्स इज अबाउट giving back to the community or creating the perfect portfolio for your CVs and your resume building. तो ETL का भी एक open source initiative है जहाँ पे we had the pleasure of Sir Kamran Ahmed join us. And Sir Kamran Ahmed is actually the founder of roadmap.sh. I'll share the links, everyone. Since we're short of time, I'll have to move past this. I hope everyone knows about roadmap.sh. हर कोई इसको use करता है. It's the perfect roadmap to start your career. And so we had him train our students on ETL online for getting them ready to collaborate and contribute to open source projects on GitHub and everywhere online. And with that, we move on to career help. As discussed before, project advisory and career help go hand in hand. FIP project advisory is about FIPs, right? Your final year projects, जहाँ पे आपको professional help चाहिए. But career help is actually career guidance and tailored advice to suit your needs. If you're lacking soft skills, we have a session for that. We have a whole program for soft skill sessions. If you want to build the perfect CV or your perfect resume, we also have trainings and career help and guidance for those as well. So career help actually curates to your personal needs कि आपने अपने आप को कैसे job ready करना है. Moving on to RIs. Miss Varda, will you take this one?
Yep, sure. So, iRise. iRise is our flagship program, which basically stands for I am rising with a real industry skill experience. So, basically, the motto of empowerment through learning is that we should empower students through learning. So, empower students through learning का मतलब ये है कि कोई भी बच्चा from any university, from anywhere in Pakistan, gets empowered through learning, and getting empowered through learning is through industry experience. There is a gap between industry and academia, and ETL Online fills that. And for that purpose, we have our program, iRise program. So in iRise program, we have a project-based online internship which bridges the gap between students and professionals. We have multiple industry professionals who are willing to share their projects and work on their projects and help students gain real industry skills experience from these internships. So when a student has gone through this internship experience, they are ready to go into the industry. So for more information, you guys have to go to our website and read from there.
Thank you so much for explaining that. And last but not the least, the mentorship program. All right, so ETL is collaborating with some FIP advisors and some industry experts with having experience more than I think more than 10 years of experience each individual is going to be having over here. और जो हमारा mentorship program है, it's going to connect university students with, of course, industry professionals like Sir Nofel Elahi over here, and we have tons of other more industry professionals signed up on our mentorship program. अब यहाँ पे क्या होगा कि यहाँ पे career decision, technical skills, real world project है कोई आपका, you want to get into a new technology, for example, you're moving from web development to blockchain, or you're moving from data science to machine learning or deep learning, you can get connected to the perfect advisor and career counselor, technical career counselor, if I so to speak, in our mentorship program. All right, so we're going to be wrapping this up and moving on to Sir. Thank you so much, sir, for waiting. since we have a lot of new students joining us, I had to explain everything. We had to get them, you know, a bit, क्या कहते हैं उसको, थोड़ी सी हमने शिनाख्त करवानी थी with the ETL platform to get them a bit familiar with what's going on and what they're in for. So we have a lot of exciting things happening, but stopping this over here. The website stuff, I'll share the links. आपके साथ feedback form भी share किया जाएगा बीच बीच में, and you can share anything that you have to or you want to. A short disclaimer, raise your hands if you want to ask any questions from Sir Nofel directly, or share your questions in the chat if you want to speak to him or you want to ask anything that is confusing you or any query that you have whatsoever. Moving on to Sir Nofel Elahi, our brilliant data architect and product lead. Sir, I won't spoil your introductions. Why don't you introduce yourself to us?
Okay, thank you so much. And I think this is a good initiative. I graduated back in 2011, and I think back then probably we didn't have this kind of a platform where the students can so easily learn, or I wouldn't say fully learn, but at least get to know what's happening in the industry, right? So when they graduate, there's so many things that you can do in the industry, right? And these kind of sessions, kind of, at least when you're at the sixth or seventh semester level, you're trying to figure out where in computer science and or software engineering or anything, where I can actually probably be more creative, probably where my interests lie in, right? And these kind of sessions like introduce you to those what's happening to the current trends in the industry, and help you identify if this probably is going to be where you want to have a career as in the future. And that's very interesting. So from my introduction, so currently I'm working in Systems Limited as a product owner, and slash as a sometimes as a data architect. Also, I help them, but I'm more into the product owner role, where I'm working with interestingly in a SaaS platform. So we are building a software as a service platform. We have built it for supply chain connectivity. What does that mean is that in industry, in if you're some business, you want to get connected to your customers, you want to get connected to your vendors, right? And there's a whole supply chain network around where you're getting your procuring your things from, where you're selling them, how are you selling them? You're selling them online via e-commerce, you're selling them in retail stores, you are getting China or Vietnam or somewhere to get the manufacture for you. So it's a very interesting space, supply chain, especially supply chain post-COVID is very interesting because COVID disrupted a lot of the world's supply chain, right? So people want to know the analytics. And then recently we have seen that with the America having a new president in Trump, they decided that, okay, we are going to have some tariffs and rechanged or redo for different countries. And now everyone is figuring out, hey, where do we get our stuff from, right? Apple is trying to figure out where to get the iPhones manufactured in, where to get the silicon manufactured in. That's why supply chain and analytics is something interesting. Before this, for over a decade, I've worked in Teradata. And in Teradata, I've worked in a lot of different domains. Teradata in itself is a data analytics platform. It's a very different platform from what we are going to talk about today, which is Hadoop. So Teradata is more of a relational database platform that has evolved. And it's also a distributed platform. It was one of the most great, I would say, distributed platform. It still is, but its use is a very different one. That's what I think we should talk about today. So I worked for a decade there, doing a lot of data projects for a lot of the big names in the industry. I did it for a year almost for BMW in their supply chain, where we had to get all the data in for their factories. I did it for Mobile Telecom, which is in Saudi Arabia, great telecom, especially during the Hajj season. A lot of tourism happens in Saudi Arabia, so there's an influx of people, and there's a race against time to have your telecom network stable enough for the 2 or 3 million people that are going to now come into the kingdom. And suddenly there's a demand for data, there's a demand for calls. Apart from this is Well, everything is interesting. I think some more introduction to me is also that I try to have a bit of a different hobbies and try out different hobbies. These days, what I'm trying out is running. I'm going to run a half marathon in the trail. So if someone loves running, someone loves half marathon, I'm doing that. I've done a lot of mountain biking in the north. I've done it in Murray. I've done downhill biking in the trails. That's something that interests me, camping and everything. So whenever I'm not working, I'm usually in the mountain trying out mountain biking. So that's a bit of a quick introduction to me. And then now we move on. So I've prepared my slides slightly from the angle of a lot of these students here are going to be from the distributed computing, right? And what we wanted to do was, hey, how and where does big data fits in, right? And then a lot of times these terms confuses a lot of the students. So what my try today is try to unravel what happens has happened over the period over the last, I would say, 20 years or so, where there's been a massive uh, different type of innovation, technology innovation, different new technologies coming in. So we try to unravel a bit of that. Let me try to move on a bit, and we can talk about what's happening there. So that's what my agenda is. Distributed systems, then introduction to big data systems. We go into a bit of history because that helps you build or helps you unravel what's inside the black box of what Google file system is, what's happening with the map reduce, what's big data, what exactly is meant by big data, right? And then we move into Hadoop with its evolution. We try to look into a bit of what are the different parts of it, where and why Spark came in, right? So a lot of people say, hey, what's Hadoop, what's MapReduce, what's Spark? That confuses, and that's what we want to not be confused about once we are out of this session. I want to give a very brief, quick overview of the Databricks platform and how you can start with it. I would, and then some real world applications, some carry tips on how to, if someone gets interested out of this session, and hey, this is something that I want to carry in, how can they start, what do they should start doing a bit more beyond their current curricula in the university, right? So why distributed systems? Distributed systems has always been an interesting thing that has gathered attention in the computer science world, that we one machine cannot do all of your stuff, right? It was probably true in the early days of the computing that, hey, when 40s, 60s, 70s, the IBM and the IBM was called the big blue and everything. But then beyond that, we saw that it wasn't scalable enough at certain point, and we wanted to have our problem divide, and we wanted to divide and conquer our problem. We wanted to like if we can have multiple resources working parallelly at the same time, right? That solves a lot of issues for us. And today, what we are going to discuss is big data, but we know that a distributed system doesn't just end or start at big data. Distributed systems are used in the content delivery network today for you, where YouTube is going to probably show you a lot of the videos that are currently cached in Pakistan, or their content delivery, or they're going to buffer the video for you, which is the network closest to you. Blockchain is another interesting field where distributed systems is coming in, cryptocurrency, right? And then there's the storage solutions, Google Drive, Box, everything. So all of these are in the end, deep down at the barest level, they are distributed computing examples. The one specific one that we are going to talk today is big data and where did this come from. An interesting thing about this is that I work in Teradata, right? And so in Teradata, I remember 14 years ago when I joined, they gave us a manual of the Teradata relational database, and it's a massively parallel programming system, Teradata in itself, right? And Teradata was started another research in 79, and historically, it had a 1 terabyte system, data warehouse system, which was being used by Walmart for their loyalty program back in 1991, 1992. So we had big data even back then, right? And there was Teradata. There was another company called Oracle who had their own software that was coming up and beyond. And but where exactly this revolution started, right? What exactly differentiated, what exactly caused the boom today for this big data revolution? And that starts with Google. Google comes into the play actually, and Google gets a search engine created, right? And the Google search engine is now crawling the web, indexing the web, giving you easy access to search back in 97, 98. And that is actually where the revolution starts. Along with this revolution, today we see it's not just Google, it's the Instagram storing all of your photos, reels, stories, everything, and using all of the data to give you personalized ads. Uber is using route optimization to give you when you call a cab, it's going to call the nearest one for you. Netflix is going to recommend you something, and all of this is going to require storing a lot of data before we even go to the fancy part of doing data analytics or data science. And so all of this essentially starts with the with the invention of Google, I will say. I'll call it an invention. So what Google did is what Google was struggling with is that and we can see a bit of a timeline. So it's 2003 where Google file system comes in. It's 2004 where MapReduce comes in. Then Hadoop project and Spark. So this is like a timeline 2003 till 2009, and then we'll talk about a lot of these timelines, what's happening. We'll see some examples of this, and the examples will help us unravel what's happening here. So in 2003, what happened is the Google engineers finally see that the traditional file system that they are using are struggling to scale for the amount of data that Google is actually storing, right? And they invent a Google file system. They invent their own file system, which was based on Java. And the important part of this file system is that it helps them replicate a lot of data on commodity hardware, right? And that is the first step. And this is where I was talking about me joining Teradata and learning about Teradata's relational database and massively parallel architecture, which is another distributed architecture, where they had all those nodes or computer nodes working in parallel to on millions and millions of rows of relational data. So where the Google comes in and Google File System says is, hey, we have built a file system architecture that doesn't need fancy, expensive server level uh, graded hardware. So we don't need expensive server level grade hardware. We can do commodity hardware. We can do hardware that is available off the shelves that is cheaper, where there's a certain way we want to store the data. We'll get into that. That makes it easier for us to scale, and then it also helps us easier to store large amount of data. So they essentially reduced the hardware cost of mm, doing this distributed computing or doing storing large amount of data in a file system. So it's a distributed file system which is storing large amount of data, but what they're essentially doing, and the keyword on the slide is the hardware, which is commodity hardware, the off the shelf, because we know that server level hardware is always expensive, right? And this is where Google comes in. Now, Google, in the next thing that Google does is that, okay, to further, now that we have stored the data, but we have to get some meaning out of the data. So by 2004, they introduced a parallel processing model, which is called MapReduce, and we'll see an example of it, how it works, of what exactly it is. And and then this inspired a revolution, right? So Google does this all, but what Google does next is, and thank you for helping me helping put it in the chat, right? So what Google does next is Google actually moves on to open sourcing the research paper where they would explain how they have built this. Where did what? Okay, so Google essentially open sources this paper, and Google says, "Hey, this is how we have done it." Right? So they have open sourced the research paper, and Doug Cutting, a employee at Hadoop, picks it up, right? And what he does is that he creates a Google's a Hadoop file system, which is inspired by the Google file system. So Hadoop file system is essentially that yeah, so it's definitely Yahoo who did it, but at Yahoo the employee was Doug Cutting who did it, and they made it open source basically. So they were working on the silo, they were trying to figure it out, and then what they did is they released it as an open source Hadoop file system. Then and when they created the Hadoop file system and open sourced it, that actually caused the huge revolution in big data. Now, and before we even move into the Hadoop's world, there are a couple of things that we should be talking about. And one of them is what exactly is MapReduce and what exactly is big data, right? So probably we can move first to the big data world, where when Hadoop file system and MapReduce are coming in, and we are talking about and we are talking about at this stage, a lot of new data formats also coming in. So what big data becomes is that it becomes about the volume of the data that's coming in, but volume was probably also something that the relational databases were handling. Velocity is the speed at which the data is coming in. Again, another thing that relational databases, which were OLAP or which were about data warehousing, they were solving it. But it's the variety and the veracity of the data where big data really differentiates from the traditional relational databases, and it kind of gets you to the unstructured world of data, right? So now I can give you an example of this. So what happens is that before these times of 2009 and 10 and even 2006 and 7, this is where new data types are coming in. For example, JSON, XML. These are the types are coming in, and now it was a really tough, cumbersome process to get that kind of a data into a relational database in a very clean format, right? And now what we are going towards is that, okay, we don't want to like spend a lot of our energy, a lot of our hardware resources to do this kind of a processing. What we want to do is that we just store the data as it is, as raw we can. And an example, a nice example is always I give of a JSON is the automated cars today, right? And they can connect to the internet and they can give you a long JSON list of whatever the car's parameters are. Sometimes those parameters might be minus, sometimes they can be plus. So the data is always changing, but your main JSON remains one string that you always parse, right? So while in the traditional world, you always had in a database a certain number of columns, and you would expect to fill all of those columns, or you will have to do a lot of apply a lot of techniques to get only the data in for the certain column for which you're getting the data. But with the JSON, you can just start dumping the JSON in the system without even thinking about, hey, is this JSON having all of the values of the array, or if it doesn't have it, right? And that's the variety. The veracity is more the truthfulness. Since you're keeping the data in the raw format, you're keeping it as close to as how you get the data from the source systems. So it's easier to do, to see how the truthfulness of the data. Another term that I'll probably talk about later is data governance. That's an interesting topic coming up. So we can talk about that also somewhere later. So this is where we stop about big data and we talk about a MapReduce. And with after MapReduce, we can go also about uh, we can go about sorry, I got distracted by the chat, but we can also go about Hadoop file system. So MapReduce, we know in computing world, whenever we are like using a new language, we're trying to learn some new tool or technique, there's a hello world for it. For MapReduce, it's always your word count example. And this word count example is very close to what the web crawling is about, right? For example, on my screen, and I'm sorry, I just moved the screen one part too much. So you can see on the left of the screen is there's cat sat on the mat, there's dog barked at the cat, cat and dog becomes friends. So these are three sentences that I have. So what exactly is going to be MapReduce here? So So if I can go on my whiteboard, and I think you can see my whiteboard. Yes. All right. So if I can go, so this first part is actually where you are sending your data, all right? So this is where your data is. I can highlight it. And what's a map is going to do? This is your map. So this is a map. Now what map is doing is just going through the whole document, just scrolling through the document.
Sir, apologies for jumping in. Can you please zoom it out a little, zoom it in actually a little? It's not
Oh,
actually
thank you.
visible.
Yeah, sorry, my screen is a bit.
Thank you.
I think now it should be fine. Yeah.
GG, sir,
So
perfect.
now, yeah. So now if you see, map is actually talking about just counting the values. It just okay, get one. So it's just assigning a value to each of the word that has come in your document, right? And then what its next step is going to do is it's going to do shuffle, right? So this is going to be a shuffle part or a sort part, right? So shuffle, sort, and I can again try to zoom in a bit. Right. So in this part, what they are doing is you're just rearranging everything. So you have got cat, it's got three values, dog, two, and one. So this is map and this is shuffle part. And then the last part is the reduce part. This is essentially what map and reduce are doing, right? And in the stuff, this is a very crude, basic example of how it works, right? And and this is what's happening. So Google file system or its open source version, the Hadoop file system, is storing the data. But this is where you're trying to sort of start making the sense. So web crawler is actually going to go in, search for the keywords, and count how many times those keywords has happened. Again, Google so Google, and I'll come back to the question also. So Google hasn't open sourced ever. It's how do they rank? What keyword should be given different value for the search engine optimization? But what Google did open source or provide you was the Google file system and the MapReduce processing engine on top of it. Can the shuffle and reduce part be done in a single process? Uh, well, on the abstraction level, yes, right? So when you are using a language to do it, but what exactly is happening at the bottom, right down at the code level, Java level, since Hadoop file system and its open source MapReduce was written in Java, because Java virtual machines is an easier way to for interoperability across a system. So essentially, it down level, it always is doing a shuffle and sort and reduce. When you're trying to write like the code, you'll probably be just writing a reduce function. So you'll just be writing a reduce function. But if you actually see the logs of it, it will do a first a shuffle and then it short and then it will do a reduce, right? And that's what's interesting about it. And that's why uh, and that's what is always interesting when we're trying to like go deep inside the black box of we can write a code we can just see, but then there's another level to writing the code that actually what exactly is the code happening, how is it's processing right down at the bottom level where the Java virtual machine, how it exactly executes the code. Combiner layer, yeah, it the combiner layer is also the same as shuffle sort. I don't think so. It's almost the same thing. So this is a bit about the map reduce, right? Now another part is the Hadoop file system, right? So we're talking about we've done a bit of a map reduce and we deep dive into Hadoop. Also, a combiner can be something like so mostly I think in the earliest version of Hadoop, the combiner part will be doing this cat1, and doing them before the map and shuffle step. So it can happen, but there are certain versions and certain implementations of Hadoop where it was just the shuffle short version would be doing it. Again, it's an open source code, right? So anyone can write how the shuffle short could execute in the reducer function inside the Java. And this is interesting also because back when Hadoop was becoming something of a big deal, uh, there were a couple of enterprise level uh, software companies that were coming up in that era, which don't exist anymore. And that's how the world works, right? Nokia was once a big, big smartphone manufacturer. Symbian was the go-to standard for the operating system for smartphones, which isn't true after iPhone. So yeah, back when Hadoop was becoming big, and this eventually happens everywhere. Uh, where there are always open source versions, and then those open source versions do translate into some enterprise versions. So Hortonworks, Cloudera, and MapR, these were the three big joints back probably over a decade ago, who were giving you the Hadoop enterprise version. So they were doing Hadoop implementations for you, and they were like solving this puzzle of Hadoop for the customers, out of which only Cloudera exists now, and they have a decent base, but they it's just not as massive now as the rest. And that's the part of the journey in the tech world. So in the Hadoop world, I think I'm going to go back into this. So the distributed storage layer, we can talk about this now, and we can then talk about the Tez also. And Tez is literally Tez as we speak in Urdu, because Tez was created as a framework by uh, people in our neighboring country, India. So here's what Hadoop Google file system proposed and what eventually translated into the HDFS or the Hadoop file system to store the data. That to store any data, what we are going to do is we are going to divide our data into chunks of blocks, and then those chunks of blocks are going to get replicated, right? So just like as we learn probably back in our metric, FSC, and O level days about hard disk drives. Hard disk drives have blocks which are stored in cylinders, right down at the hardware bare bone level. And on the cylinders, there's always in the hard disk drive, there's a spinning cylinder, there's a rotating arm that's always rotating, and to figure out where to read the data from, and everything. So in the sales, let's just say that I have a document CSV which has all my e-commerce sales, and the data is probably around what, let's say 600 megabytes of data. So, and I have a block size that's 128 megabytes. So in that block size, I can divide my whole file. So my file is going to be divided into 128, 4 blocks. The last block just gets 88 megabytes. And these are going to get stored in a round robin fashion on all of the nodes, right? So all of those nodes, so in this example, you see there's A, B, and C, and D. So I have a distributed computing system which has 4 systems, right? Plus in a Hadoop, there's always the master node or the main node, which is controlling all of this information. So there's one node plus 4, there's 5 total computing nodes which have a storage capacity. And in that storage capacity, I'm going to go in a round robin fashion. So a round robin fashion means I'm going to start from A, B, C, and D, and then I'm going to do again A, B, C, and D, and I can keep doing it till all of my blocks are stored. In the Hadoop file system, then another thing that I can do is how many times do I need to replicate the blocks? The minimum time Hadoop file system suggests it has to be 3. That's the minimum it has to be. I can go as many as I want, depending upon how fault tolerant I want my system to be. So if I have 4 nodes, I can probably still survive, I think, uh, 1 node down, right? At 2 node down, I can still work with it. I would still need to rebuild a bit of data, and then at 3 node, I probably won't be able to work. So, and this is where the cheap commodity hardware discussion also comes in again, because what I'm trying to do is I'm breaking down my data into blocks, storing and then each block of data gets replicated. And since I have 4 nodes, so each block of data is getting replicated 4 times. And now using commodity hardware makes it easy because yes. So using a lot of this commodity hardware makes replication easy, because if I was going to use some server grade hardware, then it would have been super expensive. So this is where the Google strategy comes in, that if we have to crawl the web and index all of the web for Google search engine, We need to have cheaper hardware, but if we can replicate data like this, that means we can store large and large amount of data. And if we can use MapReduce on top of it, then we can process it, we can crawl it, we can see what's happening. What will a computation to retrieve all of the data? Yeah, Ubaid, this is exactly the next challenge that comes in, right? Because if we can relate this to the MapReduce, what's happening is, then let's just say I pick up some of this data, right? I don't pick up all of the data. I filter my data. I probably pick up sales for last week of April, right? And let's just say it's in a blog this, and I want to see which product got sales done. And if I can scroll back to my map reduce function, and I can sort of make sense here on my whiteboard. So each step is going to happen, and then it's going to write it in the memory. So this map step will put all of its output, every output of the map step, it gets computed in the memory, and then it's get written down in my hard disk drive, right? So there's a lot of it's not just the computation, there's also another thing here that is IO. And well, computation over the time, because of Moore's law, has really improved, right? So computation, I don't think so has always been, but that's just my opinion, has always been a huge challenge. The bottleneck has always been the IOs, right? And but that's just my opinion. But yes, there's computation in certain opinions, it does matter, it does struggle to provide, but and there's a lot of work here also happening. So and for example, you are maintaining a log of which node is getting what data, right? So your master node, your computer is probably, if I can say that, hey, this is my node 1, not my name, right? And I can do a duplicate. This is my node B. And this, let's just go to C. And there's someone here, right? And I can say the main node, which is passing on the instructions. Okay, you store this block, you store this block, you store this block, right? It's going this in the round robin fashion to each of them and storing, and it's maintaining a log. So it's keeping in itself a log of which block of data is getting written, right? And then it's also what is doing is it's keeping information. So not it's also watching. So it's like a watchdog here that is maintaining status of each node, if it's up or online. So every node is going to communicate to it if it's always up or it's down. If it's down, then fetch the data from this one. If or this one, if these two are down, then how do we replicate the data? What happens? These are the things that happens. So it take a lot of time? It doesn't take a lot of time. A lot of the, when we it doesn't take a lot of time because processing isn't as the CPU isn't an issue. Another thing to cater for is that all of these nodes are located close to where the main node are, right? So and what do I mean by that is that in a data center where there's a racks and racks of hardware, you make sure your main node are connected in the latency, network latency between main node and the nodes is acceptable enough, I will say. Okay. So when we need the data for anything to be processed, it will take a lot of time to retrieve from the data. It does when we are considering main node and when we are considering MapReduce framework, because the thing happening here is that every time you're trying to get this data out, for example, you're just getting this data out to map it and then shuffle. Every time you're writing back, right? So uh, so we can even talk about Azure and AWS, because I don't think so cloud computing platform as Azure or AWS is exactly the same as Spark. So we can talk about that once we get there, probably in another 10 or 15 minutes. But what we want to essentially emphasize for the rest here is that each of this step does its work in memory, and then it's write down to hard disk. again in memory, write down to hard disk, or in memory, write down to hard disk, right? This is what MapReduce is. This is what Hadoop file system is essentially. And now this is where another point comes in, which is called TASE, right? And literally TASE is the Urdu slash Hindi slash, it came from the Indian community, another open source project to make it faster, make this whole processing faster. And what they try to do is that, if I can highlight, they try to do one thing, that whatever is happening here in this part, if I can zoom in again. So once you start mapping, once you start shuffling, once you start reducing, what the taste did it that, hey, instead of at each step writing it back to the disk, then reading it again from the disk, then writing it back to the disk, put this part in the memory, right? Put everything that is here in the memory, because now at this point, and this is also, you see, uh, important, because we are also at this stage looking at the evolution of computers, memory computers, hard disk drives. We are looking towards this is we're talking about 2006, 2007. So the solid state drives are just coming up. They're still something which probably aren't commercially viable enough. The memories are slowly getting bigger, right? And this is where the hardware is improving also. So when your hardware is improving, you get more cushion. Long ago, unrelated, I read about an article. I think it's called before the GUI, I think, or something. I'll share it. It's an interesting article, because remember, back in the 80s and 90s, the programming was done very differently. Today, we as programmers or software engineers, we unless we are trying to do some very constrained distributed computing or very constrained software engineering, for example, embedded processing software engineering, we usually don't care a lot about the memories and all of that till we hit the memory limits, right? But back then, uh, memory was a huge constraint, right? So essentially, when we're talking about the evolution, we also have to look at that at this period of time, the hardest drives are starting to evolve with the better RPMs in the market, and then your hardware is getting cheaper, your hardware is getting faster and everything. So MapReduce does work on unstructured data. It definitely does. It was slow, but it does, right? And it was extremely slow and extremely painful, but it was working, and it did its job. It was fine enough for that time period, and everything is fine. But now we are moving in that, hey, what essentially Hadoop file system has allowed us now is store large amount of data. But the processing of the data, as Obed mentioned clearly, is still something that's limiting, or is something that Mutahir also and mentioned that, hey, now and even Hamna's comment that, hey, the processing is something that's lagging. So it's not just it's not about the Hadoop file system, because the file system is storing data easily at a pace. It's the processing, it's what you're getting out of the data that is lagging. That's a struggle here, right, at this point. And here where we move back to our slide, and what we've covered it, the Hadoop file system, distributed file environment, the MapReduce model, and then the TASE model, right? So it's trying to do some parts in the memory, not all of it yet. And these are, I think we have talked a lot about this, the slow read writes of the disk, it's batch processing. We are also talking about that now with storing large amount of data, the data scientists and the machine learning community wants to explore, hey, where we can jump in, and how can we utilize this data, but we are still struggling with the real-time things. And for example, in today's world, what we can do, a practical life example is the credit card frauds, right? You need to have a near real-time system, machine learning trained model that is checking in near real time if a transaction is fraudulent or not, right? So it's trained on an old data set, and this is but we are trying to like do it in a very real time environment way, that, hey, uh, This is going to be like if you don't do it near real time, then probably a lot of credit frauds can happen, which happen in the world, right? Obed, when it comes to the replication and redundancy, will it waste a lot of resources or storage? No, the storage was is the most cheapest form of hardware today, right? It's super duper cheap, and that's what's helping us with all of these distributed file systems. That's what enabled the distributed file systems. That hey, the storage is getting super cheap. That's the idea and the goal behind it. Is it a waste? I won't say the waste only is measured when it's in terms of the dollar value. That if I'm spending way too much dollar, even today when we're talking about big distributed systems, the storage hardly costs a few dollars, right? It's the CPU, it's the memory that's costing you a lot, even when you're trying to switch something on in the cloud. So yeah, jobs takings hours, not a lot of real time, not a lot of programming, sport. Writing code for MapReduce is also something where uh, a lot of like you need to know a lot of Java, right? And you don't have a lot of those Excel. So there's a very small community of Java developers. And remember that we are talking about a time where another important thing coming up, relational databases are doing data warehousing, right? And people are very, very familiar with SQL, right? So, oh yeah. So people are, and I'll get back to that, Mudahir. So people are familiar with SQL a lot, and Java is not something that the data people who are in the field of data are familiar with. They're familiar with SQL. So another project that came out of Facebook was Hive. And Hive is still in used, where Facebook was to using Hive to which provided you a SQL layer. So it gave another level of abstraction to MapReduce. You can use SQL to do it. I think, yes, Mutahar, I can explain replication a bit again. So let's go back to the whiteboard. So let's just say, where can I pick a laser pointer? Yes. So I can pick a laser pointer. So I think, yeah. So remember, see, I have a file called sales.csv, right? And what's going to happen is that if I want to store this file in Hadoop file system, Hadoop file system works like this. So Hadoop file system works like this. So in the Hadoop file system, you're going to uh, break your data into a number of blocks. So let's just say that this data was broken into these many blocks, and then this block gets stored on node A, then this block on node B, node C, and node D, and now I'm replicating it. So every node is is one, you can say, computer, right? So so all of these are one computer in a big distributed computing world. So these nodes are distributed computing nodes. So on all of these, I'm going to replicate. So this block of data is here, it's here, it's here. So I've replicated it 3 times. What this helps us with is that now if because I have 4 nodes, so even if one of these nodes go down, so let's just say node A goes down, so I still can access block one by node B. I can still access my data. So this data is available on node C and D. So I do if even if I don't find it on node A, I can do it with C and D. If I don't find this one, I can do on D and B. Another thing is that it also, and this is the thing that I missed, but thank you for the question that it helps me bring this topic up again, that if let's say Mutahir, you are using it, I'm using it, and I'm accessing the same data, so I can probably be provided the data from this, and Hadoop is intelligent to provide you data from here, and this helps in uh, mm, workload management, in load balancing, that which node to use for which data, which node from which the data should be served, if any node has more computing resources available, memory available, or everything. This is also important. What if you lost the data? I think because each server is a life cycle of what if you lost server node Okay, let's answer this question. Have I, yeah, let's answer this question. So usually when what happens is in the if you're like obviously so, that's where the commodity hardware comes in, that if there's going to be life cycle of 5 to 10 years, you're always going to retire the old computer and you're going to add a new computer. So whenever you're going to, let's say node D wasn't added, now you got node D added. Hadoop provides you with a way to store all of the data. So it gives you a platform where you can rewrite the data to the new nodes while you shut down the old one, right? And it can auto do it also. So it can auto do it. You also have further types of backups. Remember, even today, the most perhaps best form of storage is still tape storage, right? There's still organizations, there's still banks out there which are using apps tape storage for data. So if it's very critical data for the biggest financial companies out there, it's going to be probably going to be stored in some tapes, which is going to surprise you that where our computers don't have CD-ROMs anymore, the corporate still uses tapes. Uh, Now, Hamna's question. Companies like Microsoft and Meta require Java or CPP for their data structures role. They do. So if you're going to apply in those kind of roles, because this is what's important, because we'll talk about it in probably when the topic of Spark comes up. So when we talk about Spark, I think I will probably answer this question. If I don't, just remind me at that point that I can answer it. So now, just to give you a recap, what we have done so far. So if we go back on a recap, we've talked about why, we've talked about a bit of the evolution, the Google file system, MapReduce, big data, Hadoop and its evolution. We have talked about how Hadoop file storage works, how MapReduce works. So this is where we are, and we talk about now Apache Spark. We talk about Databricks. Those are the two important topics where we can move into, and that will be interesting now. So Spark comes up as something, as a need where we're storing a large amount of data, but our processing, as I told you, was lagging, right? So we couldn't process the data at the same scale. And now we have a lot of data that is available, which can be used for different kind of insights and analytics and a lot of that work. And we cannot utilize it. A lot of companies just still they're just storing those data in silos and they just cannot use it anymore. And that's where Spark comes up, which is a research project from University of California, Berkeley. Uh, I think the CTO is still the co-founder of Databricks. Matthias, I think is his name, if I'm not wrong. And what Spark does it is provides an in-memory computing framework. It's so, and interestingly, Scala is the language of choice that was used to build Spark. Remember, Hadoop was, as we discussed, was built on JD on Java, and Scala is something that can work perfectly fine with Java virtual machines. So Spark was a project that was done to a framework essentially that can do it in the data. And so and this is now what makes it interesting, because now we have a framework available that helps you move your data in memory and operate at a scale, or do a computing at a scale that wasn't possible with MapReduce or the Tails framework. And obviously, the people who created Spark, they open sourced it, and they open sourced it. They donated it to the Apache project. I think when we started this session, there was a talk about open source and and giving it back to the open source community. So this is what they did. They built a framework, they open sourced it, gave it to the Apache Foundation, which is the biggest foundation, right? So and any, I think uh, most of the open source projects eventually Apache Foundation keeps them, manages their code base, manages their licensing, also helps. You can raise requests if you ever find any issues with the open Let's say you find a bug in the Apache Spark today, you can raise a request there. Hey, I found this bug, or you can talk about it on the forums. So this is interesting, doing work with the open source. And I really liked how you also had like a part of doing the open source work, because yeah, definitely there's not a lot of interest in Pakistan about open sourcing. And another thing is about how the software licenses work. So probably after this session, there's something, a couple of things that you people would like to interest. Hey, how do software licensing works in the open source world? Can be a good question. Well, I think Essen gave a good answer about big data is about handling the data, where data mining is digging deep and getting the extracting the insights, right? So, and big data is essentially we're trying to define a certain kind of data, which is like complex, which can be multi-structured, semi-structured, unstructured, any that kind of a data. Data mining is analyzing, interpreting patterns and everything. Uh, And I think, Talha, I'll keep your question towards the end of this. I think we'll have a lot of time for those questions, hopefully. So we'll keep it for that. So now Spark is the natural evolution, because we saw that a lot of our time was being wasted by writing the data back into the platform. So if I go here, this part, and this part was always time consuming. And Spark now is a framework written in Scala, which is compatible with the Java, which can Scala can run on the Java virtual machines. And Hadoop was also already is based on Java. So it was easy to install Spark alongside Hadoop file system and use Spark to eh, do what Ubed wanted to do here, probably, which is data mining, right? Look for what's inside this data. And how Spark works now. This is the next topic for us today. That okay, how Spark works. So how Spark works, if we move, Spark uses something called resilient distributed data sets. It's again the same kind of concept that we're using in I think what we can say is MapReduce, where we are trying to not MapReduce in the Hadoop file system. So while we are storing the data in a Hadoop file system, we're breaking the data, right? And we're breaking the data to store it across the distributed computing, and then we're replicating those blocks also. Right. And now we are moving towards something called, okay, uh, RDDs. What exactly is this? And then this is where the basic definition is again the same. We are breaking the data and then we are dividing it into the and fitting it into the memory of each node. So instead of trying to, so what we did was the, hey, if you go here, can I fit this data in the memory when I'm trying to do some data processing, when I'm trying to do some uh, when I'm trying to do some data processing, when I'm trying to go into dig into the data, do data analytics. How about I just fully load this data into the memory of one of these nodes, right? So I load all of this data in the memory of each of these nodes, because finally the computer hardware evolution is at this stage and Spark enables it. And now I can in memory work on this data via resilient data sets. So resilient data, distributed data sets are essentially these chunks of data that are getting fit into the memory. If they're not getting fit into the memory, they're cached in the storage, obviously. And if you want to access that one that's in the storage, then obviously some piece of data from the memory will be swapped with the cached one, and the cached one will be moving out. So this is where RDDs comes in, right? So, and that's the secret sauce. Uh, and we talked about one key concept here, which was black boxes and digging deep. And this is, unfortunately for us, when we talk about Spark, a lot of times today, what we can do is we can just, this is, I can probably for 5 or 10 minutes, I can show some bits of that, the how Spark works, right? You can write a Python code, it can do Spark processing, something on data. But what it's doing deep inside is that it's going to break this data into small chunks, fit it into the memory of these distributed machines. How many of you have them? And then work on this data. Also, another concept that comes here is uh, the directed acyclic graphs, right? And this is important to know also, that directed means that there's going to be from one direction to the other, right? So there's going to be uh, from one point to the other. The other one is that, hey, it's going to be acyclic. So acyclic means that it's never going to have a loop or a cycle, right? So it cannot just go back to something. It's going to go from point A to point B. And what happens is that it optimizes the task execution. It gives a file some sort of, you can say, you get a one direction of how the data processing is going to happen. Another important part is that Spark doesn't execute immediately, right? So if you're writing the code, it builds a DAG of all the operations that you're going to perform. And I will see what the DAG is, how it's going to build that. And then it's just going to apply that when you're going to finally execute the code. So it's when you're writing the code, and when you're executing the code, before that it actually optimizes itself. It builds a whole plan. Okay, this is how my code is going to get executed by breaking it into the data into resilient data sets, and then performing whatever operations you're performing on it. So for example, here we were seeing a file which was named sales.csv, right? So what it essentially is going to do is that, hey, Nofel wants to see sales for the month of May 2025. So I'm going to do a filter of May 2025 on the, and then another thing that I want to do probably is I want to see the sales for product X, probably a watch, because I see a watch in front of me. So all of these filters, the code is just getting built up. So first it's just going to write all of these operations as a DAG, and then it's just going to uh, execute it in one go. And since it's going to do it in memory, it's going to be 100 times faster than whatever MapReduce was. And thank you, Mustafa, for again iterating about the main features of Hadoop file system and its fault tolerance, right? And this is now where Spark is getting interesting now, because everything is happening in memory. You are breaking your data in memory, fitting it in memories, and now we are also talking about where memories are getting big, right? Uh, Remember, the computer that I'm right now connected on and is using Zoom on is a 32 gigabit system. But I'm talking about, if you're talking about distributed computing, they're probably going to have 500 to maybe 700 something GBs of RAM. If you have 10 nodes, that's probably going to be like 6-7 terabytes of memory. And now 7 terabytes of data that you can process at a time, fit it in the memory distributedly. That's what the scale of Spark is. And initially it was, again, it was created with Scala for the Java interoperability. But over the time, Spark has evolved a lot. There's this now SQL framework for those old school like me, whose work started with SQL. Uh, Many of you are very, very great, brilliant kids who are into the software engineering and can do much more complex things than even I can do with Python and any other programming language. And Spark provides you APIs or provides you interfaces to work with all of those languages. Spark SQL was one. Then another one came in was MLib. So machine learning libraries got built in to the Spark. Structured streaming, again, streaming data, and got very important for where we are trying to, like, I think we talked about real-time fraud detection. That's where Spark ecosystem evolved. GraphX is a very, very recent addition, because another interesting topic in the computer science world is graphs, where we're trying to, like, know which object is connected to which in the whole world, and these graphs can get very complicated. I talked about myself in being in product owner role for a software which is for supply chain, right? And supply chain is a lot more connected because let's say I'm Nike, I am probably going to ask some vendor in Vietnam to create some new shoes for my running collection, right? And then I'm probably also going to uh, sell them online on Amazon. I'm going to sell them on Nike.com. I'm also going to sell them through some retailer in America called Foot Locker. There's going to be some, and so how do the shoe come to like the port? Who is going to be the custom clearing agent for it? Who's going to ship it to the last location? Who's going to handle the logistics? These are going to be so many companies for me. How are they connected to me? I want to see graphs. So this is where within our data sets, which data points to get connected. That's where GraphX comes in. And another interesting example of this is how Facebook or Instagram shows us very personalized people do you know basically, and how do they do that? They do that by a concept of seeing how the graph of people. I'm connected to X, X connected to Y. So hey, probably enough of your uh, connected to Y, you can add him as a friend or something. And these kind of real world examples are interesting here. Uh, yeah, so app algorithms. Al one way of them can be machine learning libraries, Hamna. The other way can be the graphs, GraphX algorithms, or how graphs are built on top of data. So how my data relates to each other. Both of them can be something. Uh, There's one thing, yeah, definitely I've missed, and I think this is the perfect time we can deep dive into Talha's question. So Talha is working as a lead data engineer, and what they're looking at is they have a lot of big data tools that they've looked in. The Apache, there's Kafka. It's not going to be Apache because Apache is going to be Talha Foundation that looks after the open source tools. So what you're going to look into are going to be Kafka and Hadoop, and you're going to create a data engineering pipeline. So uh, what can you talk about this potentially parallelizing and distributing processing and storage? And then you also have talked about the Parquet format. I think I haven't talked about Parquet format, but we at this point, I think this is going to be a very natural evolution to the Databricks. I think we can talk about the Databricks platform a bit, and we can talk about how Databricks platform comes here in. So this is where Tala, your question now naturally gets us into Databricks and all of these platforms. We've seen Hadoop file system. We talked about Hadoop. We've talked about MapReduce, how it works. We have talked about evolution of Spark. So where does Databricks comes in? So you see, if I'm going to install all of these softwares, it's going to take a lot of time for me. It's going to be a big challenge because what I'm going to do is I'm probably going to go on an Apache's website and download each of them. So first step, I will probably be downloading Hadoop file system, right? Because I need the storage first. And then I will have to install it. I will have to set up my own distributed cluster. For to do that, I need to know the networking. How do all of these computers going to connect to each other? I'm going to install a software, uh, probably an open source software that is going to manage the distributed computing environment, right? And then I'm going to install Hadoop file system, and I'm to have to make sure, okay, Hadoop, these are going to be my distributed computing nodes. These are going to be the main node where you are going to sit as the brain, and you are going to play with all these nodes. So right, you're at the top, you're going to manage all of these nodes, and you're going to manage how the data stores. This is your first step. You have managed to install Hadoop file system, right? What's your next step? You're going to then probably install Spark, let's say, right? Now you're going to install Spark. You're going to give it all of the configurations of the Hadoop file system. Hey, this is how my Hadoop file system is installed on this distributed computing platform. This is how you can access the data in it, and this is how the Spark works. Now you're going to manage Hadoop. You're going to manage Spark. You're probably now talking about getting the data into the system, right? So you're going to probably install another tool. In the open source world, there's Apache Airflow. a tool that you can bring the data from anywhere and land it and then do all of this. Um, So that's one way to do it. And that's a hectic way to do it. And there's companies who can do it. There's companies who have to do it because they have some security requirements. Government agencies, probably. I remember I've worked with a credit bureau where we didn't, and this wasn't a constrained way, where a credit bureau in Pakistan. So what's a credit bureau does? Credit bureau does essentially is give us a credit rating that, if Nofel goes and asks for a loan, or Nofel asks for a credit, they see the history across all the banks, across all the accounts that I've opened in banks or in any financial institution I've opened accounts, and then they give me a credit score. So another credit company, if I go to another credit company, they can see here Nofel hasn't done a credit card fraud, or Nofel hasn't done anything like uh, probably it took a loan and haven't returned it, right? So that's what the credit bureau is doing. But in Pakistan, what the constraint that we got was we have to do it uh, in their own data center. So now we have to do this whole installation ourselves that I explained to you. So these are the kind of constraints where we usually do these kind of things, where there's a budget constraint. You pick up everything open source, the licensing is not an issue. But remember, there will be bugs in open source, and then there's no way to go. And the other part of it is obviously that the other part of it is obviously that there's some uh, there's some compliance requirements from the government agencies and everything, and that helps us. That doesn't help us, but that puts us as a disadvantage where we have to do everything ourselves. Or the other way is that, and this is what the Spark creators did, that hey, we have created a great platform that can be used for data processing. So, which is Spark, but nobody has the time today to do all of the install everything themselves on a bare metal hardware, right? You take it from the scratch, you install everything yourself. So they provided an off-the-shelf enterprise platform, Databricks, right? The disadvantage that comes with it is obviously the cost associated with it, because now you're going to get a subscription of them. You're going to set you're going to and that's going to be a little more expensive, but the upside of this is you don't have to manage all of the networking between the distributed systems nodes. You don't have to maintain how the Spark works, and you also don't have to take the headache that hey, tomorrow a new version of Spark comes in. How do I upgrade to the latest version, right? Tomorrow a new version of the file system comes in. How do I do it? So they provided Databricks. Another important thing here is that Databricks is also a cloud only platform. It's not an on-premises platform. So there's two differentiations here. On-premises are something that we do locally. We have our own hardware in some dedicated data centers, and we have everything installed there. Databricks isn't a platform for that. It's a platform in the cloud. You go up to them, you sign it up. I'll show its interface. We'll get a bit of a familiarity with its interface, and what it eventually helps us with, it gives us that one window and a dedicated space, and lets me get right to my job, which is to get the data in, start the data analytics. I don't have to go through the headache of how do I install, how do I manage my platform, right? So these are the headaches that it moves away from. Now, and the next question from Talha is another interesting one, which I think something that we can talk about, and uh, also is Parquet format. So what's happening is the Parquet essentially is a format that helps you store compressed data. So remember, data is always stored. There are a couple of things that you always do to data, either when the data is in motion, so data is moving from one place to another. For example, my video right now is moving via this Wi-Fi bit by bit. It's encrypted, right? That's one thing. The other one is compression techniques applied to send the data uh, uh, um, uh, efficiently, right? You don't want to, right now I have my video on, it's probably lossless compression applied by Zoom on it and encrypted to send it via their server to your screens, right? And this is where Parquet format comes in. So over the time, and the formats of the data have changed, which helps us to store the data in a more compressed way. It also further enables us that we talked about resilient data sets, RDDs, and since we have now compressed the data and we have built compression techniques, it helps us to load more data in memory to apply the Spark programming framework on it. So your data is always going to be in Parquet format unless there are challenges to it, Talha. But usually you try to store the data in the Parquet format and it works with it. Another important thing here, remember with Databricks is the Databricks platform when comes up uh, on top of the cloud providers, right? So what are the cloud providers? There's three major cloud providers, but there are others also in the market. Uh, and I think I'm scrolling up because there was a question about cloud also somewhere, uh, which I'm missing. But essentially, yeah. So cloud computing frameworks, Azure, AWS, that was a good question from Essen. Uh, so Databricks is available as a platform on top of your cloud providers. Cloud providers are Amazon, which is the Amazon Web Services, Azure, which is the Microsoft Cloud provisions. And we know what cloud computing is. Cloud computing is essentially helping you uh, move away from setting up complex data centers yourself, setting up your own data centers, storing your own data and everything, leaving it all of those complexities to the cloud providers. They set up their data centers. You just go to their interface. You just check, okay, I need this service in the cloud, and you just pay as you want. You can pay by pay as you go. You can do an yearly subscription, monthly subscription, and because if you're going to set up your own data centers, you're eventually going to uh, reach a limit at some point. You will have to scale it. You will have to replace the hardware yourself, as one of the questions came in 5, 10 years later. What happens with the data? You don't worry about that in the cloud, right? Microsoft probably is retiring all of the platform behind, uh, and you don't even know if they have retired the hardware, or if there was a hardware fault and they've shut down a server. It's all abstraction for you in the cloud. You don't need to keep a large team to manage your data centers. Microsoft is doing it. So Databricks comes up as a platform on top of cloud to work with this data processing, to work with big data, to work with data storage. The couple of changes that happen with Databricks, especially in the cloud, is the cloud providers have their own file storage services, which are object storage, which are different kind of file storage where everything is as an object, and you cannot update that object. You always have a new object coming in, right? So slightly different than the Hadoop file system. To make it a bit different, I think I'll write in chat also something that I think post this session you probably can try having a bit of look at. Oh, why can't my chat go in? Okay, sorry. Meeting group chat. Yeah, so Delta Lake. So this is a way where Databricks has provided an abstraction layer on top of the cloud storage. So now it's not Hadoop file system that's working underneath Databricks. What they are using is they're using Spark. They're using Spark on top of an abstraction layer, Delta Lake, and beyond that, they're using the object storage, which is the S3 in AWS, which is your BLOB, ADLS, BLOB services. You don't have to worry about them, but Delta Lake is something interesting that I haven't made slides about, but something that I will leave it to you guys' curiosity to learn more about later. So now, and this is interesting that the focus is that over the time, Databricks platform keeps on evolving, keeps on getting to a point where you can easily ingest more and more data. You can process it faster. You can do data mining, analytics, and they start giving you more and more feature for data engineering, for machine learning, for streaming analytics, everything, right? Data engineering is essentially getting the data in, putting it in a format that is something that can be used by the data analyst to see the patterns in the data, to do basic kind of analysis in the data. Machine learning is where you're starting to like do some advanced analytics on top of data. It's always easy to data mining is essentially where you're going right deep into the data and identifying the patterns in the data. You and the patterns means how do certain shoppers shop? How do certain e-commerce uh, how do certain for example on Amazon you're trying to always Amazon always is giving you suggestions. That's the basic example, right? They're using uh, personalized suggestions. In the healthcare they're trying to do DNA analysis, that's genome data. Data and there's not a lot of data difference between data analytics and data mining. I think it's more about analytics is a more broader term that is being used in the industry. Uh, with the lines blur, probably. I will say that what happens is that the whole process, right? So analytics is just not basically about going deep into the decision. It's analytics starts from how you examine the data, how you put it in a format that's important, how you model the data that it can be consumed by a machine learning model, and model a data in a way because what happens here's what's happening in these phases. When you're bringing in data, let's say you're trying to like see the patterns of how do the male shoppers shop differently from the female shoppers, right? And you don't have enough information about the gender. Uh, Yeah, exactly. That's something what it is. So data mining is just finding the patterns, but analytics is about getting the data in, not only getting the data in, but getting it into a format where it can be used for data mining. So as I was saying that, for example, what you're trying to do is you're trying to analyze how female shoppers and male shoppers shop differently, right? And you probably don't have in all of the data the gender information available, right? So you're going to make some wild guesses. Okay, I in 60% of my data, I have the information that this shopper was a male or this shopper was a female. In 40%, I don't. And there are techniques to fill in this data. We are not going into the details of that. There's a data science world. But doing all of that is the data analytics domain. And obviously the tools, Spark is one, SQL, and then there are finally there are visualization tools to how do you essentially tell your story, right? The visualization tools can be Power BI, Tableau, MicroStrategy, everything. Yeah. So slowly now we can probably go and see a bit of Spark Databricks platform. So I did a few things early, and the reason to do them early was that it's a community edition, so it's slightly slower. And it's free. So community edition is free. You can just sign on. You can just Google Databricks Community Edition. You can sign up for it. It will give you a code in your email, and you can just log in, and then you can explore it. So how does it looks like, right? So Databricks platform looks something like this. And a few things are missing here. But if you see, there's the left pane. If I open this three dot menu, or I think the UX UI people today call it the kebab menu at the top, you open it, it shows a few options here. What it essentially, and this is essentially showing you here, this is your cluster, right? This is your distributed cluster that you have set up. I can go and see the details of this cluster. Okay, this cluster is running some Databricks version, which has Spark 3.3.2 based on the Scala 2.12. So this is the open source Spark version installed in it. It's community optimized, so it's just going to have a two core node. There's some configurations, and it's just good. And I can add, there are a few more things that I can see. If you ever get to, and hopefully you'll get to play along somewhere where you work with the uh, licensed paid subscription version, you will see this there will be type of worker nodes. Okay, your main node is going to be this, your worker node is going to be that, how much RAM, how much CPU, all of those things. And obviously an important part when we start working in the industry is how do we size our platform? How do we make sure our platform is at the right size? We don't want a platform that is too big for our needs, right? Because that's going to just give you an extreme build that you don't want. You don't want your platform to be so tiny that it just doesn't fit in, and your Spark is constantly moving the data between memory and disk, and you are just not getting any real performance gains from it. There's a workflow menu again. It's not there in the community edition and community edition your workspaces, but from the people who will be in the data engineering world, for them this is where they can make their flows, that how the data engineering pipelines get set up. Catalog is where you try to actually start building your catalog of tables. We'll get to what your databases are connected, where your tables are, and everything in your data platform, which is the Databricks analytics platform. Whatever you have, any tables, any databases, any data files, everything is here. So you can explore what currently is saved, what your file system has, and you can start exploring. The most important part is obviously the workspaces, right? So if I go into the workspaces, uh, there's going to be a user list where obviously there's one user, which is me right now, and there are my notebooks. And this is what Databricks actually is very hyped about. It's something that the current data engineering world market is really looking into. Uh, the Databricks gives you a very flexible notebook. This is inspired from the Jupyter notebooks. If anyone of you is working in Python, and notebooks, what are the advantages of using a notebook, right? The advantage of using a notebook is you can have multiple cells, right? So this one is one cell. I can probably add another cell here, right? So here's another cell here. I can write a different code here. So this helps you divide your code into different logical areas that your code is about. Then what other important things are here is you can have these markdown. So markdown helps you, right? Nofel is in a session, right? And I can just, and now it's Markdown helps you write comments about it. And I see a hand raised by Obed. So yeah, Obed, I think we can perfectly fine. If you can take a question here, you can put it in the chat. I think we have time to take the questions here. Okay, probably nothing there. Uh, so this is what helps us to, and you can see another advantage in Databricks. You can work with whatever language you're familiar with. Why Python? This is another important question that comes up, that whenever we think about Databricks, there's always Python, while Spark and everything became Java. It's because over the time, Python has been the most widely adopted language. It has, if the newer versions of Python, you can do a lot more. There's a lot more flexibility to it. There's a lot more adoption of Python language. A lot more new people work in it. So there's a larger open source community. Hence, uh, Databricks eventually have provided a Spark API with Python, and there's a library called PySpark. So if you have to start with learning Databricks, if you to start with data engineering and the distributed computing, I think Python is a great way to start learning the basics of Python. And then with Spark, you need to move towards the basics of PySpark, how you can work with PySpark, how can learn the basic commands of PySpark, and then learn how you can do some very complex thing. So it helps you build your own cool format frameworks to do data engineering, to do data analytics, all of those things. And it gives you a much more flexibility than a SQL would give. That's why a lot of I think 10 years ago, they were called ETL developers, right? Today, they're called data engineers. The work is the same. Bringing the data in, you're in the end moving towards a visualization, and you're providing a story. Example of a story, I think examples are always important when we're trying to work here. Again, since my recent work has always been supply chain, so I'll give you another example from the supply chain world. Logistics is an important field. right? And in logistics, it's very important to know when will my goods reach the destination. So for example, I want to send my I have some stuff that I've made that is in Islamabad, and I wanted to ship it to, let's say, uh, Europe, right? So I need to know when will my trucks run from Islamabad, how many days it will take to reach Karachi port, how much time does it take from port to be on the ship, and how much time it will take to reach eventually the port in Europe somewhere, and the custom clearance. So all of that data and coming in, and then I want to do predictive analytics. Hey, uh, based on the past experience where I've sent my cargo via logistics company, can you give me a prediction of how much time does it take? Do you can do data scientist work like lead times, uh, how much seeing the past 5 years of data, uh, how how much less of a time I can send my cargo from Lahore to Karachi, right? But all of that kind of work, these are, I was giving the examples of stories. That's where we started from, and these stories are important to relay in the real world example. So, but we're working with the distributed systems and data engineering. Our end goal is to solve business problems, business solutions, and that's what matters. And the notebooks, you can change your languages. I think Python is an excellent. This is where I'll say learn Python, start learning Python, PySpark. We're going to get some into some basics. Notebooks, it gives you the flexibility to do anything. In fact, you cannot do some things in community editions, but as a year ago, Databricks also gave you some basic visualizations that can happen here. So now, if I can slowly start talking about what this code is, which I've, because of the slowness, I've just kept it here. Uh, is that this is a sample data, which is an array where I have three names with their ages. So I've just created some sample data and I've stored it in this array. And then I've moved it into a data frame. And now this is an important concept. What is a data frame? The data frame is essentially whenever we call a PySpark data frame, it abstracts the RDDs for you. You don't need to know how your data is going to get distributed across the memory in a Databricks environment in Spark. All it you know is your data frame is in memory, right? And that's why it's this is now making the platform a black box for us. It's hiding those abstraction levels that we have learned over the course of the session. It just says to you that, hey, this data frame is now in memory. It's that simple. Behind the scenes, all of this data is getting into resilient data sets, right? And now if I can just do a sample show, so it just shows me that, hey, this is the data that's in memory. And if I can do now, I can do some basic Python write some basic Python code. If you're familiar with Python, this kind of code should be very familiar. So all it's doing is that, hey, this second column age, it should be just +5. So it's going to just do a +5 on it, and it shows up as a new column. Super duper easy. If you want to filter, you do a filter on it, and it will all show you what's less, right? So this basic code shows you how you start creating data frames. This is very important. Then you start writing the code with whatever you want to do. And at each step, you're trying to do a show to see the effects of what you're doing. And the notebook is helping you that, okay, and you can reuse these notebooks again and again. You can publish them, you can share with your people. That's what the concept of notebook is, collaborative, helping with everyone. It can, if you want to read from a JSON, it does this. If you want to read from a CSV, file, you can do this. You can give it to path, and the path can be anywhere in your cloud storage. It can be path somewhere in your Databricks catalog that is here. So and you can just load it in the memory. You see, this is a data frame that's going to just directly load the file in the data frame. It's in memory. Behind the scenes, it's in a distributed framework, but here it's like this. And there's another session, I think. So I was just testing it out. Okay, how does the data frame and everything gets connected? And uh, and what I want you to do is that take these keywords out of this session and start exploring in especially in the big data space. PySpark, Databricks, Community Edition, you just sign it up. Uh, and where do you get the data sets to play with? That's another important question, right? And for that, I always recommend, if you go here, uh, that if you go to Kaggle, it has open source data sets, right? Kaggle is very, very famous if someone has any interest in data sets or anything. So you download those open source data sets, learn how, so I've shown a bit of Spark, so you start learning how you can load that data into Databricks, how you can perform basic PySpark on it. That helps. Databricks Academies in itself has some free courses. Obviously, the world is filled with YouTube tutorials on anything that we want to learn. So these are some of the things. Why Databricks? I will probably say that. Obed, I was talking about if you learning about Databricks, if you want to like figure out where do I get some data that I can load in the Databricks and start learning it, the data set easiest place is to go to Kaggle and download data sets from there, then upload them to Databricks and start doing your data analytics on them. Start learning how to use PySpark to view the data, do some filters on the data, or do some basic Kaggle exercises. So wherever you're going to get Kaggle exercise, you're going to go to Databricks, and then another objective of why do we want why did we show the crux of all of this is yeah. So yeah, that's where I was coming to. Why Databricks, right? So in the world of data engineering, in the world of data analytics, the hottest platform right now in the market mm, uh, is Databricks, right? And this is the most in tool in the market, the most advanced tool that people are using. Uh, to do all of these works, and that's why when I was creating these slides, I decided there can be Teradata, there can be Snowflake, there can be many, there can be platforms from Microsoft itself, there can be platform from AWS, but Databricks is obviously it's a platform that has been started by the creators of yeah, and that has been created a Spark, and they're continuously whatever they do, they also continuously give it back to the open source community. So Delta Lake, another keyword that I typed, Spark, they've given to big projects in the data engineering sphere, and that's why I think one of the in-demand tools that people should know about and should have a bit of an idea about. Uh, as they move along their journey towards graduation is this. Yes, well, the idea about is mm, so yes, it's Databricks is important for ETL. Remember that the data mining, the GPU, TPU, those kind of things gets helpful when you're really into data science and you're trying to like uh, apply some algorithms which really necessarily require you to use a GPU or something, right? Otherwise, or you can just Google whatever open source data sets you have, or for example, you're trying to do LLMs or something. That's where GPU and the GPU-based distributed computing comes. And again, that goes back to our original idea of this session where we talked about that distributed computing isn't just ending us to uh, their big data. It's the cloud data networks, the content data network CDNs. It's the cryptocurrency exchanges. That's distributed computing also, and GPU based LLM is another. This is the pure data engineering world because whatever you do, I remember in the end, for every fancy data science work, for every fancy LLM work. Uh, you need good data in your platform to to run some kind of algorithm on it. And how do you get good data in the platform? How do you clean the data up and everything? Those For that, one of the leading platforms right now in the market to learn and to know about is Databricks. uh, Distributed storage based on blockchain, I haven't, to be honest, seen that a bit, or probably that's probably because I haven't experienced that yet. It can be something interesting and something that I should also look into future. But I think you can search me on LinkedIn, so that we can probably connect on this later also if we can, because this is something I haven't explored, and we can probably see if that's something can be interesting to talk about next time. So with that, I think I just finished probably what my goal was 10 minutes early. And anything, Aska and the other session moderators that I've missed or something, or any questions so far from people?
No, sir, not at all. You did not miss. Actually, it was very elaborative and very well explained. मतलब मुझे भी session लेते हुए बड़ा मजा आया और हर चीज मुझे समझ आई अल्हम्दुलिल्लाह. It was very great. Thank you so
Thank
much.
you.
बाकी let's move to the questions, sir. Guys, आप लोगों में से किसी के questions हैं तो you guys can raise your hand. And एक्चुअल में अवेल द अपॉर्चुनिटी गाइज. आप लोगों को मतलब इंडस्ट्री एक्सपर्ट के साथ कनेक्ट इसीलिए कराया गया है ताकि आप लोगों की एक जो कंप्लेन होती है कि यार हमें पता नहीं है इंडस्ट्री में हो क्या रहा है, इंडस्ट्री डज नॉट कोइंसाइड विद द एकेडेमिया स्टडीज, तो ये सारी चीज़ें जो हैं अभी ख़त्म करने का मौका है. अवेल द अपॉर्चुनिटी एंड डू आस्क इफ़ यू वांट टू आस्क एनीथिंग. यू कैन टाइप दैट इन द चैट. लेट्स वेट फॉर 2 मिनट्स सर. 2 मिनट लेते हैं कि अगर कोई मैसेज टाइप कर रहा है या एनीथिंग, उसके
Sure.
बाद कैन मे बी रैप अप. एंड थैंक यू टू ईटीएल एक्चुअली, मतलब जिसने
Yeah.
प्लेटफॉर्म हमें प्रोवाइड किया है टू कंडक्ट द सेशन. मोहम्मद मलिक, आई शेयर हिज लिंक्डइन विद यू गाइस, डोंट वरी. वो मैं जीसीआर पे डाल दूंगी आप लोगों के, ठीक है. एंड आई विल पोस्ट द लिंक्डइन, डोंट वरी. या मे बी समवन कैन डू इट. 5 मिनट्स ब्रेक. सर ये स्टूडेंट्स है ना, तो स्टूडेंट्स का काम यही होता है 5 मिनट ब्रेक.
Yeah, this is
अच्छा जी. एनी क्वेश्चन गाइस? कोई क्वेश्चन है तो प्लीज डू आस्क. अच्छा जी. मीनवाइल इफ यू गाइस थिंक ऑफ एनी क्वेश्चंस, मैं एक छोटी सी बात कर दूं रिगार्डिंग ईटीएल के. ईटीएल ये इट इज़ अ ग्रेट अपॉर्चुनिटी यू नो फॉर मतलब आप ऑलमोस्ट 260 स्टूडेंट्स आर हियर. तो गाइस ईटीएल इज़ फॉर यू गाइस. आप चाहते हैं कि आप इंडस्ट्री एक्सपर्ट से कनेक्ट हो जाएं, ठीक है. आप चाहते हैं कि आप उनसे कोई भी काउंसलिंग ले सकें, कोई नॉलेज ट्रांसफर सेशंस करा सकें और एनीथिंग एल्स, ठीक है. ईटीएल इज़ डूइंग अ लॉट. तो डू कनेक्ट विद ईटीएल. ईटीएल का पोर्टल आप लोगों के पास है, ठीक है. आप उधर कनेक्ट हो जाएं. यू गाइस कैन कम टू मी, और मतलब आप मेरे साथ डायरेक्टली भी ऐड ऑन कर सकते हैं. यू कैन कम्युनिकेट विद मी and you guys are actually going for your FYPs next semester inshallah taala. So this is going to be very beneficial. इन चीज़ों के बगैर आप FYP मतलब if you intend to do something in machine learning or something, ठीक है, जहाँ पे आपकी distributed computing use हो रही है, तो वहाँ पे ये this session is going to help you a lot. बाकी this session is will also be uploaded on YouTube. उसका लिंक मैं आप लोगों के साथ शेयर कर दूंगी. I hope there are no questions, so let's move to Mutahir and Varda for the closing of the session. And once again, sir, thank you so very much for your time, for your efforts. It
Oh,
was really, really grateful.
thank you.
Ji Mutahir.
Thank you so much, sir, and thank you so much, ma'am, for giving me the mic. One more thing, everyone, chat में मैंने feedback form share किया है. I would like everyone to actually visit the form and submit and share your thoughts, because empowerment through learning हमने नाम ही इसलिए रखा था कि this is actually what we're trying to do. Empower all of you through learning, free learning, because you are the future of the tech industry in Pakistan. आप ऐसे बहुत सारे होंगे जो फाइनल ईयर प्रोजेक्ट्स स्टार्ट करने वाले हैं या ऑलरेडी डेवलप कर रहे हैं, और जो मे बी वर्किंग सम jobs, or you want to learn some new technologies, or maybe you're a fresher beginning first semester mein, second semester mein, I don't know where to start. ETL is actually providing all of you guidance on how to do everything in the best possible manner, following industry standards and professional practices. To share your feedback in the feedback form. और मैंने एक थोड़ा humorous सा message किया था कि if you want to see how I look like or what I look like, visit the website, go to the team section, and you can see कि हमारे वहाँ पे team के अलावा ETL mentors भी हैं who are actually really profound industry professionals, each having more than 20 years of experience in the relevant domains. So that is also something to look forward to. और आप उनसे connect कर सकते हैं on the community portal. Make sense, everyone? A little reaction, a wave of the hand. All right, I'm seeing like about 20 reactions. What about the rest of you? सबको समझ आ रही है what I'm trying to say?
I guess सबको समझ आ गई है, and furthermore you guys can
Covered.
connect with them on their LinkedIn as well. You will see that we have really remarkable and cool mentors as well and team members as well. So, with that, thank you once again to Mr. Nofel for this inspiring session, and thank you to all the attendees for being a part of ETL Online family. If you have any questions, feel free to ping me, Mutahir, on the portal. You guys can see the feature of text as well on the portal. We will be there to respond you guys. और इसके अलावा भी कोई भी query हो, feel free to ask. You guys can connect with us on our LinkedIn's as well. And
I
ETL
I
is
would
here to
I
help you
would
as
like
well.
to jump in. Sorry, Varda. Sir, एक जैसे चूंकि अब इतने सारे students बैठे हुए हैं, any sir, I would like to get some good insight from you. 1 minute ending note, sir. कि मतलब आपके पास माशाल्लाह 200 से ऊपर बच्चा बैठा हुआ है, sir. Anything you would like to say them except for the session? Anything in 1 minute, then we can wrap up.
Uh, I think it's a great कि आप लोग इस तरह के सेशंस में आ रहे हैं and you're trying to like know what's going on in the industry. And just make sure कि आप लोग out of all of these sessions uh, try to explore all of these fields क्योंकि when we are like in the 8th semester and हम graduate कर रहे होते हैं, so a lot of times there's a lot of confusion that what exactly do we want to be. So these sessions help you identify, as I said, yeah, ये शायद can be something interesting. So after every session, whatever is an instructor is saying, yeah, अच्छा ये आप try करें, go give it a bit of a try and see if that inspires you, because वो फिर आपकी FIP की direction में भी जा सकता है and आपको एक career direction भी दे सकते हैं कि अच्छा मैंने after passing out, what do I have to become? Is it going to be a data engineer, or is it going to be a distributed system but in a totally different domain? And really good to see a very interactive session. Thank you.
Sir, thank you so much, sir. Somebody has raised the hand. Zaim Ahmed, do you want to ask something?
Yes, ma'am. Am I audible?
Ji, Zaim.
Yes.
My question was, sir, is it better to be a jack of all trades and master of none, or a master of one?
I think I'm a uh, master of all. I'm a jack of all kind of a guy, right? So and that's what industry also loves, right? Industry में concept होता है T-shaped consultant का, right? So T-shaped consultant is someone who can like go across everything with a focus on one thing, but then they know everything. So for example, right now I'm a product owner in a supply chain software world, right? So my job is to do feature engineering. So I sit with the C-level executive to see, okay, what are going to be the next features in this platform? Now I can sit with the data team to identify the how the analytics and everything works. That's one side of things. I can sit with the UX UI team to see how the UX UI looks of the software. While my actual job is to actually make sure that the features get delivered. These are the new features that we're going to deliver in our software. That's my job. But being someone from the data side, it helps me to like see, okay, how the data is going to work with. And then because I'm somewhat interested in the UX UI, which is totally not my domain, I sit with the designers, and in industry we call it a T-shaped consultant. So definitely, you pick one focus area, be strong about it, but don't stop being curious about anything else either.
Okay, sir. Thank you very much.
Thank you.
Challenji, I guess with this last question, we should wrap up. The last question has been done. So, I think we are already ahead of time. Even it's 4 o'clock. So, Mutahir and Varda, kindly wrap up. Thank you.
Yes, ma'am, and thank you so much, sir. Thank you, first of all, all of you gave us your time. Thank you for joining. Or especially, sir, thank you, Sir Nofel, for this insightful session on Hadoop and Spark and Databricks. जिस डिटेल में आपने समझाया है, I don't think we actually get a lot of this insightful understanding in our academia as well. Your expertise as a data architect has truly shown through, providing us with practical techniques and real-world examples. I learned a lot personally as well, and I can say this for everyone here, I hope. Okay, we extend our sincere gratitude to you, sir, for sharing these insights and your expertise with us today.
Thank you, sir.
Thank you so much for inviting me also.
No, sir, the pleasure was all ours because we actually want people to teach us things. We're hungry for learning new technologies.
Yeah.
So with that,
Thank you,
I'll
sir,
have to
and
excuse all of you. All right, with that, I'll have to excuse all of you. Thank you so much for coming. Stay tuned and stay curious for our upcoming sessions. Portal bhi join kar lein. I have shared the link of the WhatsApp community in the feedback form as well. Usko bhi aap dekhein. And do check our website as well for more initiatives and updates. Koi bhi question ho, you can contact us always. Thank you so much, everyone, and Allah Hafiz.
Assalamu alaikum, Allah Hafiz.